Okay, number 5, let's try it. A 47.4 kilogram student runs down the sidewalk and jumps with a horizontal speed of 4.20 meters per second onto a stationary skateboard. The student and skateboard move down the sidewalk with a speed of 3.95 meters per second. Find the following. So, on the first part, find the mass of the skateboard. Okay, so some of the things that we know here. We have a student mass. Call that. So we got student mass, mass of the student. We have the student velocity. I have the final velocity for both of them. So that means I can use the factored out version of this. I know that the stationary. Okay, so that means that the velocity of the board initial is 0. And that means that I'm looking for the mass of the skateboard. Okay, so I know that the initial momentum, okay, has to be the same as the momentum after whatever action has happened, right? When we're talking about the conservation of momentum. Now here we're given the velocity or speed, because we don't really have a direction per se. The speed of the student on the skateboard, and so we know that the final velocity for both objects is going to be the same, and so I can use this factored out version that we've talked about already. Okay, in this case, it'd be the mass of the student plus the mass of the board. But in this case, I'm going to be solving for M. What do I call it? MB, or I guess I call it M2. But the main point is that we have to understand that we're trying to apply the law of conservation of momentum, which states that the total momentum before whatever action happens, right, the jumping on of the skateboard, has to equal the total momentum afterwards. So let's plug and chug some of these things here. We know that we have 7.4 kilogram multiplied by velocity of the estudiante. And we're going to add the mass of the board, but we're going to multiply that by 0, okay, because it's a stationary skateboard. This is going to allow us not to have to deal with a second m sub b, or an m2, when solving for this, and that's going to make things a lot easier in the long run here. And that's going to equal, again, the final velocity, which was 3.95 meters per second. And that's going to be M1, the student. And then, oh gosh, I messed this up. Crap. Where's my, all right. Sorry. Let's set up again. Let me erase that real quick. Get that out of there. I should be adding, and this will be the mass of the board. So here, I'm going to solve this equality for this MB. Okay? And so when I do all this together, what does it end up being? It's going to be 2, and I'll do that side in a moment. Okay, so I've multiplied out the left side, and so now I'll try to solve. I'll start my solving for the MB. So I'll divide both sides by 3.95. Don't pretend like you can't read that. That goes away. And then, after I divide this, I'm going to subtract 47.4 kilograms from both sides so that that cancels. And so my mass of the board is going to be equal to 199.08 over 3.95 minus 7.4. And this is going to end up being 3 kilograms. Oh, not on the screen. So again, the reason that this worked out is because I was able to factor out that final velocity. Again, if I had two velocities for a final velocity, I could do that as well, but I've only been given one velocity. That means that I'm going to have to use this factored out version. But even after that, I'm still going to have two different values, or sorry, two different M2s, and this can be really annoying if you're not able to get rid of one of them, right? You can still do it, but it's annoying. And so the fact that the skateboard was initially at rest, it allowed me to have this initial velocity of the board be 0, making this part of the equation go away, including this M2, which made it so this was the only M2 that I had to solve for. So once you make those assumptions and you recognize that about the problem setup, you really come down to algebra, right? And that is the rub here. Once you recognize the situation and you plug in, certain like at rest values here, you make the rest of your calculation a lot easier. All right, let's do part B here. So we have the same situation. B says how fast the student would have to jump to have a final speed of 5 meters per second. Okay. Now I'm not going to repeat the part where I defined this here. Okay. But in this situation, we can plug in so a final speed. We're going to have our M1 V1 initial. Again, I'm going to go ahead and just skip this part here because the M2 multiplied by 0 just makes that go away. So then I would have my final velocity like that. Now in this situation, I know that my final velocity is going to be that. Remember, I already have the M1, and I just figured out the M2. M1 also applies to that. So what I'm really solving for is this right here. So all I have to do in this situation is divide both sides by M1. So I have initial velocity of the student, right, the first object, which is what I'm solving for. Then I have my final velocity, M1 plus M2, all divided by M1. Oh, M2. And so this ends up with, what's my final velocity? 5 meters per second. M1 is 47.4 kilogram plus 3 kilograms. And then divided by M1 again. plug and chug, and my calculator is going to tell me that the initial velocity of the student, in order to end up traveling at a velocity of 5 meters per second, that student would have to jump onto the board with an initial velocity of 5.32 meters per second.